I wonder what would happen if I just decided to flip this cone here and put this ice cream cone on top and voila! Hyperbola! Haha. Before actually solving anything, first we need to know what exactly is a hyperbola. A hyperbola is a symmetrical open curve made by the intersection of a circular cone and a rectangular plane, which is basically the opposite of what an ellipse is, or a parabola on its side, but it's reflected over the x-axis or whatever axis as well. So there's two equations you can use. There is the x squared over a squared minus y squared over b squared equals 1, and that is when the section is going to be across the x-axis, or you can use y squared over a squared minus x squared over b squared is equal to 1, and these are both non-translated equations. The asymptote is determined depending on what type of equation you're using. So when you have the x squared first, it will be y is equal to plus or minus b over ax. If you're using x squared first, the asymptote will be y equals plus or minus a over bx. Now in order to find what your vertices and foci are, since covertices don't technically exist with hyperbolas, it's going to be a squared plus b squared is equal to c squared. Okay, so in this problem we are given the major axis of an ellipse, which is equal to 10, and the foci, which is equal to -1, 5, and -1, -7. So we are supposed to find the standard equation of this hyperbola, and we can tell that already this is going to be a translated hyperbola because of where the same number is on the foci, which is at -1 for the x value. And we also know that the major axis should be equal to 2a, like so. And so if we have 2a is equal to 10, and then we divide 10 by 2, which is going to give us our a value, we're going to get a equal to 5. And then we can see that our x value is the same, so our x value is going to be x plus 1 squared over 25. Sorry, I sneezed. Little hesitation. But okay. So then we can find how much the distance between our foci is. So we subtract 5 minus -7, but we would end up adding them, which would get us equal to 12. And then we divide that number by 2 because this is equal to 2c. And so 12 divided by 2 is equal to 6. And so we use the relationship again, c squared is equal to a squared plus b squared. And since we know what our c value is, which is 6, 6 squared is 36. And we know 5 squared is 25, which is our a value. So we can calculate what our b value is in order to get the second part of the equation. And we get b squared is equal to 11. And so we can see that y is going to be translated as well. And we can calculate how much it's translated by subtracting or adding the 6 to the 5 or the -7. And so if we subtract it from the 5, we get -1. And then if we add it to -7, like so, we would also get -1, and that is where the midpoint is going to be. So we get y squared minus 1, or plus 1, is equal to, or is over 11. And so, I'm sorry, I messed up here. It's supposed to be the x plus 1 squared is over 11, and the y plus 1 squared is over 25. And this is because you can see that the foci is going to be switched. The foci is going to be along the y-axis because that is the number that is changing, and that would also be where the a value is, since the a value and c value is also going to be on the same axis that it changes. So now we can write out the final formula. Since the y is changing and that is our a value, we would write it first. So our final equation would be y plus 1 squared over 25 minus x plus 1 squared all over 11, or over 11, and that is all equal to 1. And that's what you need to know of translated hyperbolas. The equation for a hyperbola is very similar to the equation for an ellipse, except there is a subtraction, and the a squared is always going to be first. Your a value is always going to be connected to what your vertice is, and your non-existent covertice is the b value, just like it would be with an ellipse. So the first problem that we have here is a non-translated hyperbola, which is the equation x squared over 49 minus y squared over 16 is equal to 1, and we want to find the vertices, foci, and asymptotes of this equation. So the first thing you want to point out is that what our a squared value is, and since it's always going to be the first number of the denominator, our a squared value would be 49. So we write it over here. A squared is equal to 49. And the square root of 49, as most people should know by this point, is 7. So we write a is equal to 7, and this will later help us find what our vertice is. We can also solve for what our b value is, even though we don't need to. And since the second number is our b squared value, it's going to be 16, like so. And the square root of 16 is going to be equal to 4. Finally, we know the relationship is a squared plus b squared is equal to c squared, and c squared is going to help us find what our foci is, because that is going to be the value of whatever number is necessary. So we have 49 plus 16 is equal to c squared. Once you add up these two numbers, you get 65, and since 65 is not a perfect root, we just leave it as the square root of 65. Now we know what our vertice is, and so since we calculated that 7 is our vertice, the a squared value is connected to our x squared value, so we know that we are going to be changing the x parameter of where our hyperbola is going to start. So it's going to be plus or minus, because it's on both sides, plus or minus 7 and 0, since it starts at the origin, or the center is going to be at the origin. And then we also can know our foci value, because we calculated what c is going to be equal to. Sorry, I was writing covertice, but I meant to say foci. Our foci is going to be the square root of 65, what we calculated over here. And this is also going to be attached to the x value, because this is where it's going to be on the inside of the hyperbolas, but yeah. And then finally, we can solve for our asymptotes, which is the last part of this problem. And we know that from the previous section that y is equal to b over a in this case, because our b value is connected to our y value. And we know that usually our slope is rise over run. And so we just have to plug in y is equal to plus or minus 4 over 7 x. And then we just have to sketch out the graph, and that's all you gotta know for hyperbolas. So you can see here, go up 4, then to the right 7. Okay, so now we are graphing this. So I move over to the left 7. And then I can just draw this out, since we know that it will be heading towards the asymptotes, like so. And then we do the same thing to the opposite side. Again, mark the vertex at 7. Then draw your function, or the lines that approach the asymptote. That would be -7, 0, and this is 7, 0. And then we can also draw out our foci. And since we know that the perfect square of 64 is 8, we can just assume that the square root of 65 is slightly next to where the vertices are. And that's all you need to know for non-translated hyperbolas.
All right, guys. Well, looks like you gotta go. Hope you had a good time. Have a good day. Yeah.
Thank you. Can't wait for next year.